Hello everyone. Today we will cover a small part of programming language R and solve problems given in previous video. Before starting that, let's mention that I will be using RStudio, which you can download as well, but you can use any editor you like. The comments are the same. Also, if you want to learn more about R, you can find useful tutorials, one of which is embedded in RStudio. You would just need to download some packages and you can start any of those tutorials. And in that way you can learn much more if you're interested than what we need for this course. So let's start with some basic functionalities of R. For example, we can sum two numbers. How to run the code? We press Ctrl and Enter. So we hold Ctrl and press Enter. Then we can divide, for example, and in order to start only this line of code, we need to put our mouse here and press Ctrl Enter. However, if we want to start everything before, we can go Ctrl Shift Enter. That way we start everything. And we can delete everything in the console. So Ctrl L. This is something that I will use a lot. Also, there are functions such as sinus of, for example, pi divided by 2, or logarithm of 1, for example, or similar. But what is more important for us is that we can use, for example, quantiles of chi-square distribution or normal distribution or similar. So what would you expect to get when you have 1.96 but not norm? For example, this. If this is the quantile, well, as expected, it should be 0.97, a larger number. Why is that? Well, we can always go help and do pnorm and run the code. There we will see what actually we obtained, the description and everything. So in this case, pnorm, we just need to find it, pnorm. We can see what does it in return and how can we change it. So what are the entrances? Vector of quantiles. And when we don't type anything, we use actually the standard normal distribution, so with mean 0 and standard deviation 1, and it returns a lower tail. So the probability that it is smaller than the particular number. Okay, so by looking at this, what would you expect to get from, for example, what would you expect to get from this function? So Q norm, so P is a vector of probabilities, and the rest is default. So we need a quantile. What would you expect to get? So we would expect to get 0, because this is the mean. Half of the observation will be smaller than 0. In that way, we will get that the probability that, for example, x that has standard normal distribution is smaller than 0 is actually 0.5, which we need here. Let's see. Okay, as expected, it returns 0. We can use any other functions, so density, distribution, quantile, or to generate random numbers. So D is for density, P, this is the distribution function, quantile function, Q, and random for generating random numbers from specific distribution. We can actually do that for any any function that is embedded. For example, let's see what does this function do. We can find the functions in help as well, or Google them based on what do we need. So this is the non-central chi-square distribution. Again, as a standard normal distribution, it has its density, distribution, quantile, and a random generation function for each one. So you would not need to do it yourself. You can use those. Okay, let's see how to save variables. For example, we can type x is equal to 2 plus 2. We can see that now x, or for example y, is another way. So we can see now that we have two variables, x and y, and we saved them, so those two numbers. How can we see where did we save and which values or variables did we save? So we can, for example, go ls, like list, and it will tell us x and y, or use objects. It returns the same. Let's remove this. So now, what do we have here? We did not remove those variables. They're still here. Sorry. So see, they're still in the system. One way to remove them is to go to environment, and we can see here two values. X is equal to 4 and y is equal to 4. So this is one way of the representing values that we used ls for. So it's usually much easier to just go here and look at those values. If we want to remove, we can just go clean and remove everything. Now the list should be empty, so we don't have anything. Okay, so here we used a function that are embedded in some packages or in RStudio, but we can also create our own functions, and it's not that hard. Let's first see how we can get an array. So let's say that we want our x variable, so you can either use equality or this sign to get the array. So let's say that we want numbers from 1 to 5, then we will use c 1, 2, 3, 4, 5 and run the code. Then we get our x and we have our array. Let's see what is, for example, how to get a function that computes standard deviation. But before that, let's introduce, for example, function variance that gives us variance of our vector that is inside, so variance of x, and it will return 2.5 in our case. So let's use variance to create our own function of the sample standard deviation. So let's remove this. Remember, even though I removed it, the value is still going to stay here. So let's call it as the hour. So our SD. So this is our standard deviation function. However, RStudio and R is k sensitive, so you should be careful when defining. So I usually use for function this and just type function. What are our in? It is our vector. Let's call it vector. Okay, vector or just vector. And here between those we need to write our function. So let's say that it is square root of variance of x. Okay. So when we run it, what do we get? We get a function that is called our SD, and let's see how it works. Our SD, so we can press tab, and of our x, and run it. Then we get 1.581139. So this is one way to create functions. Okay. Say now that instead we have in this function something before, so more lines of code, anything. Then the last line of the function is going to be what the function returns. So this is going to correspond to the returning value of the function. So let's say we want to print something. So if you want to learn about other things in R that we do not need in this course, you will have to search internet for that. So in this case we need print, for example. This is print the vector, let's say if we wanted to print text, and let's say we want new line after that, so we need to do n. This represents new line, then x or vec, so this is our vector. Okay, so here we need vec as well, sorry, but it works anyway because it is what it returns. And let's run this function. So this is our new function, and see what do we get. So it prints first, but our return value is still 1.5 like it used to be. Let's see what happens if we want to save this. So our value, what do we get? We just get the return value, not the print values. So we get one value. So the built-in functions in R can be found under help, for example, but still you would maybe like to Google the functions that are built in depending on what you need. We will explain all functions that we need here, but if you want something more, then you will have to search. You can also import different packages. For example, in RStudio, you can just go to packages and install whatever you want, whichever you want, and you can find them here. Also, you can get any help on any function the same way. But if you don't know the name, then you would definitely, the name of a function, you would definitely need to use Google, for example. Many functions here, let me remove this data, in R are vectorized. So in a sense that they work on a vector. So let's say that we want to play with the normal distribution, and we want vector, let's say q, as it is given in help, q of the lower quantile and upper. So we have some q, so minus 1.96 and 196. And let's see what would be norm, the one that we used before, of this q return. So it recognizes that there are two values, and as it's vectorized, it will compute for both vectors, which is actually pretty nice. We can do the same for any other function that we need. So on for example, student t-distribution, so QT, which will actually find us, so QT is quantiles for the student, so let's find, for example, QT of, let's say we want 0.05 quantile and 0.90. Okay, but we need, because it's vectorized, we need to make this a vector. Okay, and we need to specify degrees of freedom. So say we want 5 degrees of freedom. And it returns us 0.025 quantile, and so those are the quantiles of the t-distribution with 6 degrees of freedom. We can also find confidence intervals in this way. So instead of computing for each value, we can compute at once, or similar, perform tests, and etc. Let's remove this. Okay. It is up on you to choose the editor, but I'll be using RStudio. Also, similar as in Excel, when you start writing something, it will suggest, it will give description. You can press F1 for additional help, and you can press Tab in order for it to, let's say, materialize. Not sure what word to use here. You can always use ls and objects from the beginning to get the variables, or just look at the environments. R can be used easily for example, regression or some plots or similar. Later we will talk more about this, but first let's see how to get or generate a matrix. Let's say matrix X, we can just type matrix, and for example we want something like this and this. So what did we get? We got a matrix 2 times 2 with values 1, 3, 4, 5. When you double click the data, you can see actually how does the matrix look like. So when we view it, it's 1, 4, 3, 5. When we go back to code, we actually get 1, 4, 3, 5. So it is our 2 times 2 matrix. Let's see what would happen if we do E, for example, and type eigen, and we guessed it should return eigenvalues, so of x. Let's see. E is a list of 2. So what does it return actually? Not just eigenvalues, but eigenvectors as well. Let's see if we do names E to see what do we get. So we get values and vectors. So the first are values. You could always click 2 times. So the first are eigenvalues and the second are eigenvectors. Let's see. So what are one way to extract them? So this is a dollar sign. So E values. What do we get? 7 and minus 1. And E, so the name is vectors. We get actually this matrix of eigenvectors. This is the reason that it's always better to, when you work in Excel and somewhere else, to use this command and get eigenvalues and eigenvectors the easy way. But usually we would like to store those values, so we could say eigenvalues and, for example, eigenvectors, and run everything. So I run the whole code. Remove console, Ctrl L. So what did we get? We get a vector and the eigenvalues. So those are the values and those are vectors. Let's open them. So this is our first vector. This is our second vector. So we have the eigenvectors, and each vector corresponds to, for example, this corresponds to this eigenvalue. The second vector corresponds to the second eigenvalue. So they're somehow ordered. So what do we get if we, for example, use matrix is equal to, say, our matrix X, and we do like this. Sorry. Like this. So what did we get? Not this one. Matrix. Yes, this one. So we get our matrix X multiplied by our vectors, eigenvectors. So it contains product of our matrix and our eigenvectors. So this is the product of matrix X and eigenvectors. So it is A times X in a sense of eigenvalues and vectors. And the other that we need is eigenvalues times vectors, and those matrices, mat and let's say 1, they should be equal. So we need to multiply eigenvalues with vectors. To do that, it's best to use multiplication with diagonal of our eigenvalues. So eigenvalues, and let's see if they're equal. So where is it? So we have, oh, sorry, maybe let me rerun everything to see what happens. I did something wrong. Oh, in matrix multiplication, perhaps I'm missing something. Yeah, so this is matrix multiplication, but somehow they're not same. Let's see, what do we get? Okay, so minus 3504. Okay, so we actually get the same, but for some reason this returns false, false, false. Let's rerun it. I'm not sure why, but they should be equal. So it is AX is equal to lambda X. So those two matrices should be equal, as you can see here. Let's talk a little bit about coefficient of correlation. Okay, sorry. Let's remove it, everything. So let's first, for example, generate random numbers from normal distribution, and let's generate 50 random numbers. So those are our random numbers from standard normal distribution. And let's see what is Pearson coefficient. So for example, we can do, because I know the function, I can do the help. However, you would perhaps need to Google. So here we can see the variance, covariance, correlation. But in the very first lecture, I mentioned Pearson, Kendall, and Spearman correlation coefficient. And Pearson, it just tells us about linear correlation, and the other two are more general kind of dependence. But let's compute a couple to see how does it work. So we can, for example, compute correlation between r and r times 5. And we get 1, so the correlation is 1. Then correlation of, let's say, exponential of r and, let's say, again exponential of r. What do we get? We get 1. The relationship is linear. Let's do the same, but with, is it linear? We don't know. Let's do Kendall's. Kendall. What do we get? We get 1 as well. Let's do something similar, but with multiplying. We get 1 as well. Okay, but Spearman, we get 1. So this is one way, but let's do something more interesting, because here we knew that we will get 1. Let's remove everything and go to the example where, for example, we have some data r1, or let it be x1, 0, 1, 0, or let's say small data, 0.1, 0.3, 0, 0.2, 0.3. Better actually. It is totally random. And let's say y is equal to something like maybe 7, then some larger number, then a little bit smaller, like, but between, let's say 8, corresponding to 4, it would be larger, so 3, and say that those two are like 7.5 and 7.5. I was looking for a particular set. Okay, so we have x1 and, maybe I should call it x2. And let's see, between x1 and x2, so this is Pearson, it tells us about linear correlation. Then let's see the same, but Kendall and so it is easy to compute if you ever need. Method, say Spearman. So what do we get? We can see that they actually differ for this data. Can we conclude that the relationship is linear? Well, it's a question. Let's remove everything but leave the data. So we can look at, for example, plot x1, x2, and it will return us the scatter plot x1, x2. Let's change something like, because it cannot be seen really nice. For example, if we can change it like here, so we have our data. And because the sample size is like only 6, it is not really enough to see if there is a linear relationship, but we can gather more data and see. So we will see that later on other examples. Okay, let's try to solve some problems that we had before and import data. We will do that only for the one of the problems, as it is going to be the same for all others. So just, let's say, the one with the most amount of data. So the problem number 4. Okay, my data is in text file, so I will use read table. So my data is read table file, and then we need file location. To get the file location, you can go where your text file is, click Ctrl Shift right click on the file. There you will see copy as path. You can just click on copy as path and it will be copied. So you just copy this. And our separator is nothing in my text file. If it is comma, you can type comma or anything. So here for R we need to add everywhere those slashes. So you need 2 slashes everywhere in order for it to recognize. I do not know a fast way to do it, so if anybody knows, you can comment. Let's see what happens when we run it. So we get our data. We get actually 42 observations. Before, in previous video, we got 41, so perhaps I did cut one row. You can check which one, but there is no need to do that. Okay, so let's see our data. So we have 42 observations and 7 variables. So 42 times 7. One of the interesting things in R, more interesting than in Excel, is that you can just write summary and data. When you do that, you can get for every variable minimum, first quantile, median, mean, third quantile, maximum. So this is one of good things. Also we can plot. Now the plot should look a little bit better. So say that we want to plot first and second variables. So what should we do is write data and take with $sign first one. So this is our first column, and take from data with $sign our second column. Let's see what happens when we run it. We get some kind of scatterplot. However, we can see, because our data is like this, that the perhaps marginal dot plot would be better. We can always change color to the plot and similar, but we will not cover here that. Or plot whatever we want to see how our plots look like, and we can change the names similar. So this is not important for now. what do we need is covariance and correlation matrices. So let's remove this. Okay, let's leave data. When you click on it, you can see everything. So let's, for example, do covariance of what do we want of our data. What will happen? It will return us covariance matrix. If we want correlation of our data, it would return our correlation, the sample correlation matrix, which is much easier than in Excel. But you do not have to understand the computation of those to compute it. So you can just type this and you will get the result. But what you need to do is understand all these values and how to compute them. So to understand them, computation step by step in order to fully have a grasp of multivariate statistics and multivariate analysis. Let's remove first. I actually removed the data as well. You can create your own data frames, but let's keep it for now. So we showed how to get eigenvalues, eigenvectors, and found covariance and correlation metrics and some general introduction into R. So this is just something that we will need in the future, but we will cover everything step by step. So until we cover something new, we'll leave it at this. Thank you for watching and see you on the next class. Bye. This is it for this lecture, so see ya. Bye.